All right, let me show you how to do a circuit diagram. So this is circuit worksheet C, and we're going to go through and evaluate this diagram, and then we'll answer the questions afterwards. So let me show you how you do this. It's pretty complicated. We'll start at the top. So I'm going to start up here at 120 volts. So I'm starting from the top of this, the positive side of the battery, and we're going to put that at the top. It then comes down. And the first thing we have to figure out is what's the equivalent resistance of these two resistors in parallel. Remember, the way you do that is you go 140 reciprocal plus 210 reciprocal, and then you find the reciprocal of that whole thing. Okay, so parentheses 140 recip plus 210 recip, close parentheses recip. It takes about 20 seconds. So the equivalent resistance here is 84 ohms. And we're going to put that over here as our first resistor after we come out of the top of the battery. So this is going to be 84 ohms right there. Next comes a 16 ohm resistor. And then right here, a big deal, a critical thing happens right there. It splits. So the current splits at this point. Some goes down here straight, and some comes around the corner and goes down here. Remember, the current's trying to get back to the 0 volt end of the battery. So it's trying to get back around here. So some electrons are going to go through this way, some electrons will go through this way, and you're going to be able to tell me exactly how many go each way. So every time you come to a node like this, what you're going to do is you're going to draw a horizontal line. So this is this node right there, okay? And on this side of the node, it's just a 150 ohm resistor that goes down to the bottom. So I'm going to put 150 next to that. On the other side of the node, it runs into these three resistors in parallel here, which we're now going to figure out the equivalent resistance of that. So parentheses 120 recip plus 150 recip plus 200 recip, close parentheses, reciprocal, the whole thing, and that's going to turn out to be 50. So I will always make these work out evenly. You know, that's why it comes out. Normally, if you do this, it's not going to come out to a nice number, but I've picked all the parallel resistances here, so they'll always come out to be a pretty nice number. So that's going to be 50 ohms on that side, okay? And then after that, it comes down here and it hits two light bulbs, two 25 ohm light bulbs. So we'll do this the way that Blanca says to do it. You put a circle with an X in it for the light bulbs. And they're both 25 ohms. And then after that, it comes back to this node over here. So when it gets back to the node, we get back to a horizontal line again. And then it just goes to 0. And this is 0 volts here. The way engineers denote ground or 0 volts is they usually put a whole bunch of lines. And it's at a little bit of an angle. So you put 3 lines at an angle, and that's ground. Okay, so there's our simplified, somewhat simplified circuit. Now what we're going to do is we're going to do it over again one more time, because this is a pretty complicated circuit. So now we're going to go back up here to the 120, and I'm going to put in the 84. I'm going to put in the 16. And now what I'm going to do is I'm going to figure out what the equivalent resistance to this big set of resistors in parallel here is. So you can see pretty easily there's 100 ohms on this side, and there's 150 ohms on this side. So, you know, what's the equivalent resistance in parallel of that parallel circuit? So this is 100 ohms here. Remember, in series, you can just add them up. So 50, 25, 25 is 100. So 100 ohms on this side of the parallel circuit, 150 on that side. So what's that equivalent to? Well, let's do a parallel resistance equation here. 150 recip plus 100 recip, close parentheses, reciprocal, the whole thing is 60 ohms. So this big mess of resistors here is equivalent to a 160 ohm resistor. So after that, we go all the way down to 0, and this is 60 and 16 and 84. So So altogether, you can see this adds up to 160 ohms. All right, so once we get, so you go left to right, make the circuit diagram simpler and simpler and simpler till you get it down to where you can figure out the total resistance of the entire circuit. In this case, it's going to be 160 ohms. Once you do that, then you figure out the current, and the current is going to be voltage, 120 volts, divided by 160 ohms. So voltage divided by resistance is current. So 12 divided by 16 is going to be 0.75 amps. So we know the overall amperage in the circuit, the overall current in the circuit is going to be 0.75 amps. So think about that. Complicated circuit, a little bit simpler. Simplest circuit. Once you get the simplest circuit, then you calculate the current. Now, once you get the current, we're going to go back the other way and calculate voltage. So first step I'm going to do is I'm going to take that 0.75 amps and I'm going to multiply it, because voltage is current times resistance. So I'm going to multiply that 0.75 times 60 to get the change in voltage from here to here. So delta V between here and here is going to be I times R. So that change in voltage is the I times R. So that's 0.75 times 60, which is 45 volts, 45 volts. So if this is 0 and the change is 45, then this right here must be 45 volts at that point right there. And where is that on this other diagram? Well, that's above the 60 ohm resistance, which is right here. So 45 volts is going to be the voltage right here at this node here, okay? Now we do it again. Once I get 45 volts here, I'm going to repeat that. Now I'm going to do 0.75 times 16. That's the next resistance up here. So times 0.16, that's going to be 12 volts. So there's a 12 volt change from here to here, which means this up here is going to be 57 volts, I think, right? 45 plus 12 is 57. And that means there's going to be 57 volts right here. Okay, right there. This 45 volts, of course, means that right here there's going to be 45 volts, right? So this corresponds to this point right here. And the 57 corresponds to A. So right up there, between the 16 and the 84 ohm resistor is going to be 57 volts. One more, 0.75 times 84, 0.75 volts times 84 ohms, is going to be 63 volts between here and here. If I add 63 to 57, I get 120. So, you know, that's just a check at the very end. It'll always come out that way if you've done everything correctly. Okay? So now we figured out all the voltages in this, well, let's say we figured out the voltages in this circuit over here, right? Now we're going to calculate the voltages in this circuit. We know the voltage here, but we don't know the voltages through here. So that's what we're going to be able to calculate right now. Once we get voltage, the next thing we figure is current. So the current comes down, some of it goes this way, some of it goes this way. We have to figure out how much current goes either way. We know there's 0.75 amps up here. How does that 0.75 amp split? Some goes this way, some goes this way. To get current, you always take current is going to be change in voltage divided by resistance. So the resistance on this side, of course, is going to be, over here is going to be 45 volts. So between here and here is 45 volts divided by the resistance between there and there is 150 ohms. So the current coming this way is going to be 45 divided by 150, which is going to be 0.3 amps. So 0.3 amps on this side. And that, of course, means if it's 0.75 altogether and 0.3 here, it must be 0.45 over there on that side. But just to double check, I'm gonna calculate that. So the voltage between here and here is 45 volts. The resistance between those 2 points is 100 ohms. So 45 over 100, and you can see that's going to be 0.45 amps on this side. Okay, so 0.3 amps goes to the left here, 0.45 goes to the right. Once you know current, then you can calculate voltage. So if I know there's 0.45 amps going through here, then I can calculate the voltage change there. So right from here to here, the delta V is going to be the current times the resistance. The current going through here is, we just figured, is 0.45 amps. The resistance right here is 25. So I go 0.45 times 25 to get the change in voltage from here to here. So 0.45 times 25 is 11.25. So right here is going to be 11.25 volts. And then I'm going to do the same thing to the next 25 ohm resistor. It's a light bulb, but it's the same as a resistor. So I just double that, so times 2, and that'll give me 22.5 volts here. So we're calculating voltage. I think we know voltage in every single part of the circuit now. Okay? One more thing to calculate, and we're done. So we've got all the voltages throughout the circuit. We've got all the current throughout the circuit, except, so we know over here there's going to be 0.3 amps going this way, right? 0.45 amps coming down here. But right here, the current splits again. So some of it comes down and goes to the right, some of it goes straight, some of it comes down and goes to the left. So you can tell me, and you're going to have to tell me, how much current goes through each one of these resistors. And again, the way we do it, the way we find current is equal to voltage divided by resistance. So I is going to be V over R. So if I want to know the current coming through here, I have to find the voltage between here and here and divide it by the resistance between there and there. So I know the voltage up here is 45 volts. I know the voltage down here is 22.5 volts. That's from over here. Remember, right above the second light bulb is 22.5 volts, so right in there. So I figure out the voltage is going to be 45 minus 22.5, which I think is 22.5. So the current through here is going to be 22.5 volts divided by the resistance, which is 200 ohms. Okay, so 22.5 divided by 200 is 0.1125 amps. So right through here is 0.1125 amps. And you could calculate these other currents through these other two resistors the exact same way. But I don't think I need any more than that. So I think I just have you do it one time. So let's go down and fill in the questions now. I think we can answer every single question. So A, the equivalent resistance to 140 and 210, we figured that was 84 ohms. Equivalent resistance 120, 150, 200, that was 50 ohms. Total resistance, the entire circuit is over here, 160 ohms. Find the current at A. Let's see, where is A? Right there. All the current goes through there. You can't go any other way. So the current there was 0.75 amps. That's the current that was right up here. Yeah, right there, going between the 84 and the 16 ohm resistor. So right there is 0.75 amps. Voltage read at E. Right here is between the two light bulbs, and that's going to be 11.25 volts. We calculated that over here by doing the current through here, which is 0.545 amps times 25 ohms, and got the change in voltage from 0 up to there is 11.25. What's the voltage at A? Voltage at A is 57 volts. We calculated that earlier. Voltage change, the delta V between A and B. A and B, well, this is 57, this is 45. So that was that change in voltage over the 16 ohm resistor. And we got that to be 12 volts, I think, right? 45 or 57 take away 45 will be 12. So the difference between the voltage between here and here is going to be 57 minus 45, which is 12 volts. Delta V between B and C. B and C, that's when we just calculated here. That was 22.5 volts, I believe, right? 45, take away 22.5. So 22.5 volts. How much current flows at B? This is what we just calculated, the last little thing here. Hope I wrote it down, 0.1125 amps. How much current flows at D? D is over here, and that's going to be how much current flows through this branch, and we got that to be 0.3 amps. That's the difference in voltage between here and here, which is 45 volts divided by 150 ohms. So that's how much flows through this part of the circuit here. If we wanted that, now this is tricky now, so we're going to change things, okay? So we've calculated all this stuff going on in this diagram. Now in part K, I want you to do a different question. We want the 210 and the 140 ohm, this is tricky, to have an equivalent resistance of 60 ohms. What additional parallel resistor would we have to add to achieve this? And show how you found it. So what we have right now is I've got it comes in and goes like this, a 140 ohm resistor and a 210 ohm resistor, and that's equivalent to 84 ohms. What I want to do now is I want to add an additional resistor down here in parallel. So this is X, I don't know what it is, so I want the whole thing to have a resistance of 60 ohms. So I want this to equal 60 ohms. Okay? So how do you calculate that? Well, you put it into the equation, you solve for X. So it's going to be like this. It's going to be 140 reciprocal plus 210 reciprocal plus X reciprocal, the whole thing reciprocal, has to equal 60. Right? That's our equation. It's got to equal 60. So how do we solve that? Well, you take the reciprocal of the reciprocal. So when I take the reciprocal of -1, raise it to -1 power, it's just going to be 1. So I raise both sides to -1 power. And then I get rid of the parentheses. Parentheses aren't doing anything. And now I bring over this 140 reciprocal, take over the 210 reciprocal, so I get this. X the reciprocal equals 60 reciprocal minus 140 reciprocal minus 210 reciprocal, and that will equal X reciprocal. But I don't want X reciprocal, I want X. So I take the reciprocal again, and X is going to equal 60 reciprocal minus 140 reciprocal minus 210 reciprocal, reciprocal that whole thing. So on your calculator, you do it like this, parentheses 60 recip minus 140 recip minus 210 recip, close parentheses, recip of the whole thing, and it's 210 ohms. So if I add another 210 ohm resistor in there in parallel, the overall resistance is going to be 60 ohms. And of course, you could check that by putting it back into the equation. Put it back in here for X, and make sure it comes out to be 60. Okay, so another question, how many watts? So we haven't talked about this yet in class, but the watts is the power dissipated by the light bulbs. I'm just asking about the light bulbs now. And the formula for watts is voltage times current across the what we're looking at, current squared times the resistance, or voltage squared divided by the resistance. So the easiest one to use here usually is going to be I squared R. So power equals I squared times the resistance. So that is the current through there, we got to be 0.45, so it'd be 0.45 squared, and then the total resistance is 50 ohms. So I'm going to take 0.45, is that right? 0.45 was the current through there. 0.45 squared times 50 is 10.125 watts. 10.125 watts. So this is power, just like mechanical power is force times distance divided by time. The units are watts. Same thing for electrical power, except it's amp squared times ohms is going to give us power. So that's the front of the sheet, and the back of the sheet, we'll do a different time. I'll have to show you that some other time. So practice this. This is worksheet C. So if you want to go back and practice worksheet C, you can watch the video and check your work and see if I did it right. The answers are on the back, so you should go through and check those.